Today, chemistry, class 9, chapter 1. Matter in our surroundings. Here, regarding Panch Tattva: air, earth, fire, sky, and water. Panch Tattva: air, earth, fire, sky, and water. According to them, everything living or non-living was made up of these 5 basic elements. Early Indian philosophers classified matter in the form of 5 basic elements, that is the Panch Tattva. Modern scientists have evolved 2 types of classification of matter based on their physical properties and chemical nature. Physical nature of matter. Matter is made up of particles. Here an activity: take a 100 ml beaker, fill half the beaker with water and mark the level of water. Dissolve some salt sugar with the help of a glass rod. Observe any change in water level. What do you think has happened to the salt? Where does it disappear? Does the level of water change? Here you are putting salt in water. What will happen? This is the physical nature of matter. In order to answer these questions, we need to use the idea that matter is made up of particles. What was there in the spoon, salt or sugar, has now spread throughout water. How small are these particles? The SI unit of mass is kilogram. The SI unit of volume is cubic meter. The common unit of measuring volume is liter, 1 liter, 1 dm3, 1 liter, 1000 milliliter, 1 milliliter, 1 centimeter cube. The particles of matter are very small. They are small beyond our imagination. Particles of matter are very small. They are small beyond our imagination. We cannot imagine that how small is the matter. Characteristics of particles of matter. Particles of matter have a space between them. Particles of matter are continuously moving. Particles of matter attract each other. Particles of matter attract each other. Now, here questions. Which of the following are matter? Chair, air, smell, almonds, cold drink, and smell of perfumes are matter. Now, second question. Give reasons for the following observation. The smell of hot, sizzling food reaches you several meters away, but to get the smell from cold food, you have to go close. Answer. Here one thing I will suggest you: pause the video and you are able to write question answer. There is a quite strong force of attraction between the particles of a liquid which holds them together, but the force is not strong enough to hold the particles of the liquid in fixed positions. So by applying greater force, a diver is able to overcome the forces of attraction present among the particles of water and hence cut through water in the swimming pool. Next question. Here this is the give reasons. To first, the rate of diffusion of hot gases is much faster than the rate of diffusion of cold gases released by the cold food. This is the answer of question number 2, and before this I have discussed question number 3. Now question number 4. What are the characteristics of the particles of matter? Characteristics of the particles of matter: very small, have a space, constantly moving, attract one another. States of matter. Main things we have to discuss. States of matter. The solid state. Solid state, definite shape and definite volume, and force of attraction is greater in comparison to another forms of matter. Liquid state. The rate of diffusion of liquids is higher than that of solids. The gaseous state. We have observed that gases are highly compressible as compared to solids and liquids. The liquefied petroleum gas, full form of LPG, CNG, full form of CNG, compressed natural gas. Due to its high compressibility, large volumes of a gas can be compressed into a small cylinder and transported easily. Now questions answers. The mass per unit volume of a substance is called density. This is the definition of density. Arrange the following order of increasing density: air, exhaust from chimneys, honey, water, chalk, cotton and iron. Here I have written answer of this question. Air, exhaust from chimneys, cotton, water, honey, chalk, iron, the order of increasing densities. Tabulate the differences in the characteristics of states of matter. Comment upon the following: rigidity, compressibility, fluidity, filling a gas container, shape, kinetic energy and density. Solid, fixed shape and volume. It cannot be compressed. High densities. Do not fill container. Heavy, not flow. Liquid, not fixed shape but definite volume, not compressed. Less dense than solids, not fill containers, completely flow easily. Gases, neither definite shape nor definite volume, compressed easily, very low densities. Gases fix containers easily and flow easily. Give reasons. Question number 3. A gas fills completely the in which it is kept. A gas exerts pressure on the walls of the container. A wooden table should be called a solid. We can easily move our hand in air, but to do the same through a solid block of wood, we need a karate expert. Very important question. A gas have high kinetic energy. Due to this, constantly moving in all directions and fill completely. Due to high kinetic energy, moves with high speeds, thus the pressure exerted by a gas is due to the constant collisions of the fast moving gas particles against the inner walls of the container. A wooden table is solid. It is a rigid object having a definite shape and a definite volume. Air is a gas. The extremely weak forces between particles of air can be overcome easily, due to which we can easily move our hand. In air, while blocks of wood are very closely packed, it needs 4 number. Liquids generally have lower density as compared to solids. But you must have observed that ice floats on water. Find out why. Now answer. When water freezes to form ice, then empty spaces are formed, giving a cage like a structure. Because of greater volume, the density of ice decreases. Here density will decrease, so ice floats on water. Now, can matter change its state? Here, can matter change its state? You know different forms of matter: solid, liquid, ice. An example: ice, water and steam. Solid as ice, liquid as the water and gas as water vapor. Effect of change of temperature. On increasing the temperature of solids, the kinetic energy of the particles increases due to the increase in kinetic energy. Here kinetic energy. The particles start vibrating with greater speed. Here it will vibrate with greater speed. The energy supplied by heat overcomes the forces of attraction between the particles. The particles have their fixed position and start moving more freely. Here it will move freely. A stage is reached when the solid melts and is converted to a liquid. The temperature at which a solid melts to become a liquid at the atmospheric pressure is called its melting point. Try to keep this in your mind. The melting point of a solid is an indication of the strength of the force of attraction between its particles. Force of attraction. It shows force of attraction. Now next thing, the melting point of ice is 273.16 Kelvin. Here K means Kelvin. It is the SI unit of temperature. The process of melting, that is change of solid state into liquid state, is also known as fusion. When a solid melts, its temperature remains the same. So where does the heat energy go? Now next thing, we must have observed during the experiment of melting that the temperature of the system does not change after the melting point is reached till all the ice melts. This happens even though we continue to heat the beaker, that is, we continue to supply heat. This heat gets used up in changing the state by overcoming the forces of attraction between the particles. As this heat energy is absorbed by the ice without showing any rise in temperature, it is considered that it gets hidden into the contents of the beaker and is known as the latent heat. Here try to keep in mind this definition of latent heat. The word latent means hidden. Here what is the meaning of latent? Hidden. The amount of heat energy that is required to change 1 kilogram of solid into liquid at atmospheric pressure at its melting point is known as the latent heat of fusion. For water, the temperature is 373 Kelvin. 100 degrees Celsius, 273 plus 100, that is equal to 373 Kelvin. Solid state, heat cool. Liquid state, heat cool. gaseous state. It means solid state. If you will heat, it will change into liquid state, and again heat, that will be gaseous state. And now cool, what will you get? Liquid state. Again cool, that you will get solid states. It means 3 states of matter. Now regarding Kelvin. Kelvin is the SI unit of temperature. Here 0 degrees Celsius is equal to 273.16 Kelvin. For convenience, we take 0 degrees Celsius, that is equal to 273 Kelvin. After rounding off the decimal, to change a temperature on the Kelvin scale to the Celsius scale, you have to subtract 273 from the given temperature, and to convert a temperature on the Celsius scale to the Kelvin scale, you have to add 273 to the given temperature. Now effect of change of pressure. Here in this figure, solid, fusion liquid, vaporization gas, and here solid sublimation gas and gas sublimation solid. Here figure arrow you may observe. Liquid solidification solid. Now next thing, atmospheric pressure. ATM is a unit of measuring pressure exerted by a gas. ATM, atmosphere is a unit of measuring pressure exerted by a gas. The unit of pressure is Pascal. You know, you have already studied all these things regarding Pascal in class 8. 1 atmosphere, that is equal to 1.01 into 10 to the power 6 Pascal. The pressure of air in atmosphere is called atmospheric pressure. The atmospheric at sea level is 1 atmosphere and is taken as the normal atmospheric pressure. Now questions. Convert the following temperature to Celsius scale. Temperature on Kelvin scale, temperature on Celsius scale plus 273, 27 degrees Celsius. Second, 573 Kelvin. Simply 573 minus 273, 300 degrees Celsius. What is the physical state of water at 250 degrees Celsius, 100 degrees Celsius? Gaseous state, liquid state, and as well as gaseous state. Hence at 100 degrees Celsius, here at 100 degrees Celsius, water changes into its gaseous state. Now next question. For any substance, why does the temperature remains constant during the change of state? It is so because the heat supplied during the change of state does not increase the kinetic energy of the substance and no rise in temperature takes place. Fourth, suggest a method to liquefy atmospheric gases by applying pressure and lowering temperature. Simply you may write. Evaporation. You all are familiar while you are in the class 5 water cycle. Evaporation. Here, do you always need to heat or change pressure for changing the state of matter? Can you quote some examples from everyday life where change of state from liquid to vapor takes place? Here, evaporation, liquid to vapor, without the liquid reaching the boiling point. Here, it may be possible there will be not reaching the boiling point. Water, when left uncovered, slowly changes into vapor. Wet clothes dry up. What happens to water in the above two examples? Factors affecting evaporation. What are the factors? You must have observed that the rate of evaporation increases with an increase of surface area, an increase of temperature, a decrease in humidity, presence of water vapor in the atmosphere, humidity, an increase in wind speed. How does evaporation cause cooling? What happens when you pour some acetone on your palm? The particles gain energy from your palm or surroundings and evaporate, causing the palm to feel cool. After a hot sunny day, people sprinkle water on the roof of open ground because the large latent heat of evaporation of water helps to cool the hot surface. Why should we wear cotton clothes in summer? During summer, we perspire more because of the mechanism of our body which keep us cool. During evaporation, the particles of the surface of the liquid gain energy from the surroundings or body surface and change into vapor. The heat energy equal to the latent heat of evaporation is absorbed from the body, leaving the body cool. Cotton being a good absorber of water. What things? Cotton being a good absorber of water helps in absorbing the heat and exposing it to the atmosphere for easy evaporation. Why do you see water droplets on the outer surface of glass containing ice cold water? Let us take some ice cold water in a tumbler. Soon we will see water droplets on the water surface of the tumbler. The water vapor present in air on coming in contact with the cold glass of water loses energy and get converted to liquid state. Loses energy and gets converted to liquid state. Question: why does a desert cooler cool better on a hot dry day? It is due to evaporation of water. Here rate of evaporation is increased, so a desert room cooler cools better. How does the water kept in an earthen pot become cool during summer? It contains a large number of extremely small forces in its wall. Water which is kept in earthen pot evaporates by taking the latent heat of vaporization. So the earthen pot get cooled. Why does our palm feel cold when we put some acetone or petrol or perfumes on it? These materials evaporate and palm feels cold. These materials require latent heat of vaporization. Why are we able to sip hot tea or milk faster from a saucer rather than a cup? Here it is depend on area of the container. It depends on the area of container. A saucer has a large area in comparison to a cup. In large area, evaporation is faster. So we are able to sip hot tea or milk faster from a saucer than a cup. What type of clothes should we wear in summer? The cotton cloths are good absorber of sweat. Here, cotton clothes are good absorber of sweat. The evaporation of sweat from cotton cloths takes the latent heat of vaporization from our skin. Now fourth states of matter. Now scientists are talking of 5 states of matter: solid, liquid, gas, plasma and Bose-Einstein condensate. I have already discussed 3 states of matter: solid, liquid, gas, plasma. fourth state of matter is plasma. Try to understand. The state consists of super energetic and super excited particles. These particles are in the form of ionized gases. What is this? Ionized gases. In the form of ionized gases. The fluorescent tube and neon sign bulbs consist of plasma. Inside a neon sign bulb, there is neon gas, and inside a fluorescent tube, there is helium gas or some other gas. The gas gets ionized, that is, gets charged when electrical energy flows through it. This charging up creates a plasma glowing inside the tube or bulb. The plasma glows with a special color depending on the nature of the gas. The sun and the stars glow because of the presence of plasma in them. The plasma is created in stars because of very high temperature. You know, in sun, hydrogen is changed into helium. Bose-Einstein condensate. You know about Bose? Satyendranath Bose. He was an Indian scientist. In 1920, Indian physicist Satyendranath Bose had done some calculation for a fifth state of matter. Building on his calculations, Albert Einstein predicted a new state of matter, the Bose-Einstein condensate. Eric A. Cornell, Wolfgang Ketterle, and Carl E. Women of USA received the Nobel Prize in Physics for achieving Bose-Einstein condensation. The BC is formed by cooling a gas of extremely low density, about 100,000 the density of normal air, to super low temperatures. You can log on to www.camp4kids. Now what you have learned. Matter is made up of small particles. You know this thing. The matter around us exists in three states. The forces of attraction between the particles are maximum in solids, intermediate in liquids, and minimum in gases. The spaces in between the constituent particles and kinetic energy of the particles are minimum in the case of solids, intermediate in liquids, and maximum in gases. The arrangement of particles is most ordered in the case of solids. In the case of liquids, layers of particles can slip and slide over each other, while for gases there is no order. Particles just move about randomly. The states of matter are interconvertible. The state of matter can be changed by changing temperature or pressure. Sublimation is the change of gaseous state directly to solid state without going through liquid state, and vice versa. Boiling is the bulk phenomena. Particles from the bulk means whole, of the liquid change into vapor state. Evaporation is a surface phenomena. Particles from the surface gain enough energy to overcome the forces of attraction present in the liquid and change into the vapor state. The rate of evaporation depends upon the surface area exposed to the atmosphere, the temperature, the humidity, and the wind speed. Evaporation causes cooling. Latent heat of vaporization is the heat energy required to change kilogram of a liquid to gas at atmospheric pressure at its boiling point. Latent heat of fusion is the amount of heat energy required to change 1 kilogram of solid into liquid at its melting point. Now question answer. Here also you should keep these things in your mind. Quantity unit symbol. Temperature Kelvin K, length meter M, mass kilogram kg, weight Newton N, volume cubic meter M cube, density kilogram per cubic meter kg per meter, pressure Pascal. Convert the following temperature to the Celsius scale. $293 minus 273 20 degrees Celsius. 470 minus 273 197 degrees Celsius. Convert the following temperatures to the Kelvin scale: 25 degrees Celsius to 373 degrees Celsius. Simply add 25 plus 273, that is equal to 298 Kelvin. 373 plus 273, that is equal to 646 Kelvin. Give reasons for the following observation. Naphthalene balls disappear with time without leaving any solid. Naphthalene can undergo sublimation, hence they disappear. We can get the smell of perfume sitting several meters away. It is due to diffusion. The perfume vapors move up very rapidly in all directions in air, mix up with air particles and speed in the air, so we can smell the perfume. 4 number. Arrange the following substances in increasing order of forces of attraction between the particles: water, sugar, oxygen. Oxygen, water, sugar. Give 2 reasons to justify. Water at room temperature is a liquid and iron alumina is a solid at room temperature. Simply, you should write definition of liquid and solid. It means liquid, either a solid or liquid, either a liquid or a gas. Before this, question number 5. What is the physical state of water at 25 degrees Celsius, 0 degrees Celsius, 100 degrees Celsius? Answer: A, liquid. B, either a solid or liquid. C, either a liquid or a gas. 6 number answer: fixed volume and shape. Fixed volume and shape. Fixed shape and volume. Why is ice at 273 Kelvin more effective in cooling than water at the same temperature? Because for melting, each kilogram of ice takes 3.34 into 10 to the power 5 joules of its latent heat from that substance, and hence cools that substance more effectively. On the other side, water at the same temperature of 0 degrees Celsius cannot take away any such latent heat and so does not cool it more effectively. Now next thing, what produces more severe burns, boiling water or changing water into steam? Water absorbs latent heat of evaporation. Since steam gives out much more heat than boiling water, it causes more severe burns. You may pause the video and you are able to write answer. Now next thing, name A, B, C, D, E and F in the following diagram showing change in state. A is melting or fusion. B is vaporization. C is condensation. D is freezing. E is sublimation. And F is also sublimation. So all these things are in this chapter. And one more suggestion to my humble viewer: humbly subscribe my channel SK Singh Bikramganj. Thank you. Have a nice day.